Hello, in this lesson, I wish to select some questions from homework um, before midterm exam, or after midterm exam up to week 8, especially week number 8. I would like to select some questions to go over them. So you would, so hopefully this will help your review. We have covered up to 3.3 before the end of week number 8, so the homework is assigned accordingly. Let's look at the rules we have. We have the flashcards right here. We have done, the rule of the derivative constant equals 0. We have proved them. This one we didn't prove, but it's pretty, obvious. And addition rule, subtraction rule. And this one we didn't quite go over in class, but we will talk about, we will use it when we need it, we will talk about it. Okay, so now we know that e to the power x, the derivative to e to the power x is the same as e to the power x. To pay attention when we take a derivative of a quantity, we must know that the derivative is taken with respect to what variable. So here, e to the power x, right? So x is the variable. And product rule, quotient rule, which we have proved in previous lessons, you're not required to be able to do the proof, but it will be really helpful that you understand the proof. And even better yet, you can do it on your own. And so that way, when you apply the formula, it would be much easier and you don't feel you have to memorize so much. These two limits, very useful limit. We use it to prove the derivative sine and cosine, right? And the derivative sine is cosine. And of course, we have derived the derivative of all the trig functions, all 6 trig functions. And so this homework covers, all of these contents. So we got to, this time we got to practice. If you look at the first set of homework, differentiate these functions, right? For example, if you have f of x, right, we're gonna put it as example number 1, right? For f of x equals to e to the power 5. Well, even though this is in an exponential form, but e is a constant. So this function is really derivative of a constant. And the derivative of a constant with respect to x is nowhere to be found. So x is not in the expression. So the derivative of this function is 0. Okay, so the derivative of e to the power x to the power 5 is 0. Okay, so we apply the derivative of a constant. Other questions, and it depends on what you want to apply, right? Say, for example, I'm going to choose a question which is right here, example number 2. And this question goes like this. It goes like H, capital H, okay, of u equals to 3 times u minus 1 multiply u minus 2, right? And if we take a derivative, we'll be taking derivative with respect to u, because we don't have x here. So u is the variable. When we differentiate this, there are multiple ways to do it. One way is that you apply product rule. You can treat it as a product. But you can also FOIL and differentiate according to addition and subtraction, right? So if we rewrite h of u, if we FOIL, we shall get 3 times u squared minus 6u minus 2u and plus 4. Combine like terms, right? Combine like terms, the negative 6u and 2u minus 2u, that makes minus 8u. So we got this polynomial. So when we differentiate, okay, h of u with respect to u, you can just simply write h prime of u. Usually in this case, if by default we know we were differentiating with respect to u, well, you can also write it as derivative with respect to u, and that is the function h of u. Right? So get familiar to use these notations, okay? And you can also write it this way, because h of u is equals to, in this expanded form, it's like that, but make sure you put a parentheses. And then we can use addition subtraction rule to differentiate. And what do we get, right? According to addition subtraction rule, so we can differentiate individually, derivative of 3u, derivative of 8u, derivative of 4, right? So that's, you can see that's applying the rule of derivative on addition and subtraction. And put a parentheses if you want. Right, so we're applying these rules. And of course, as you're getting better, you probably can do this faster than I. And now the 3, the constant, can be brought out, right? So you can bring the 3 outside. So derivative with respect to u, now you have u squared. Subtracting, an 8 can be brought out, right? So the derivative du with respect to u. And plus, 4 is a constant. So here we can just put a 0, or we just remove that term entirely. Okay? And just one more step. And this is the time you can see we can apply the derivative of x raised to power of n, right? So we have something. Then you say, oh, we have n, and here we have x, and now we have u. Well, x is just a placeholder. It's just a placeholder, right? So when you compare this, right, derivative of x raised to the power n with respect to x. So now we derivative x squared, u squared with respect to u. So this is really just 2u, 2 times u. And the derivative of u with respect to u, that's just 1. And 0, we can remove that term. So in the end, we get 6u minus 8. And we're done, okay? And the other way, of course, we have learned product rule. You can also try product rule, right? So, so I put or product rule. So we do for fast forward. We got product rule right here, right? Product rule. They're both with respect to u, so you can, if you use a product rule, then you don't need to FOIL. Okay, so this piece will be done with product rule applied to it, which is the derivative of 2 products, which are right here. So we're applying product rule. If we apply product rule, the product rule is right here. We have proved it in the previous videos, so you can look at it, right? So by this time, you just follow the rule, right? It's with respect to u, and these are with respect to x. You just replace x by u. So over here, you will have the derivative of the f of x, right? So you consider this is f and this is g, right? So f, we keep the f, and we differentiate with respect to b, which is u minus 2, right? Plus, okay, g put in the front, and we differentiate with respect to f. So f is this piece. Okay, and then what do we get? We got derivative of u minus 2. We can apply the sum, right? The sum. And the derivative u, derivative 2, the derivative 2 is a constant, derivative constant, so that's going to be 0. So we got 3u minus 2. So we apply the subtraction, right? So that's going to multiply by 1. Plus, right? The derivative of, you know, you can just, let me show you this. Just a little bit more details, okay? The derivative of, derivative of u with respect to the u minus, the u, and now here is d of 2 with respect to the u. That's how you write it down properly. And this piece is 0, of course, right? And plus, same thing, okay? On the other side, you have u minus 2. We apply the rule, right? So you derivative with respect to 3u, so you can put the 3 in front, right? So this is right here. Okay, du minus derivative of 2 with respect to du. So that's the proper way to write it. You can skip this step entirely. You can really skip this step entirely. Okay, but if you show it, and then you can show it that way. Okay, so make sure you get familiar with the notation. As you're getting better, really, you don't need to have so many steps. And right here, du minus du over du, of course, that's 1. Okay, 1 minus 0 plus u minus 2. And here you have 3 times 1, right? 3 times 1 minus 0, right? The derivative of constant. So you're really just applying these rules, like all at, at different stage of your derivative finding. Let's organize the term. So 3u minus 2 multiply 1, right? So that's 3u minus 2 plus, over here, this is a minus 0. 3 times 1 is 3. So we have 3 times u minus 2. And we just combine like terms. Okay, so we're gonna have 3u minus 6 plus 3u minus 6. Wait. Oh, no, minus 2. Sorry, this is minus 2. No wonder. And in the end, we have 6u minus 8. We should get the same answer. Minus 8. And that's it. How many steps do you need to show? How many steps do you need to show? You can go from here, right? directly here if you wish. Really, that's still getting better. Okay, I was just showing you that all these different rules are being used, right? As you're getting better, you just differentiate that. You apply product rule, and just a couple of steps, it's sufficient. Sufficient. All right. Let's see. Number 23 on the first set of homework. Okay, so we have a y. This is going to be the example number 3. We got x squared on the numerator plus 4x plus 3 divided by square root of x. What do we do about this derivative? Example number 3. Example number 3, yeah. You can do by quotient rule, right? You can also do it by reducing it and then use addition subtraction rule. This question actually showed up in the homework of 3.1. So you could make it, so I'm going to show you 2 different ways. Okay, I'm going to show you 2 different ways. The first way, if you want to use addition subtraction, which you're going to use the algebraic skill, and you reduce this piece before the reduction. Okay, so the numerator, right? Each one is divided by the same denominator. The same denominator. Divided by the same denominator. There. Okay, then you reduce each individual term. This is x raised to the power of half. Okay, and this is of course x raised to the power half. Let me see if I should make the fonts a bit larger. Let's see, 250%. There we go. Okay. And that piece, if you like to, you like to be consistent, right? So you can write it as x raised to the power of half. There's more than one way to do it. Okay. So algebraically, we're going to apply the base to the power of m divided by base to the power of n, the bases are the same, equals to base raised to the power of m minus n. So x squared divided by x raised to the power half, we're going to have x raised to the power of 2 minus half. Okay, plus we have the 4 here, and x raised to the power 1 minus half. Minus half. And last is 3 times, right? This is a 1 over x raised to the power half. So that's just x raised to the power of negative half. You probably understand we're trying to use this derivative formula. We're trying to use this derivative formula, right? For this derivative formula, n, the power can be any real number. So we have numbers, like we have some fractions, and those are fine. We can apply it. 2 minus half is 3 half, right? 2 is 4 over 2. 4 over 2, right? So 4 over 2, right? And that's 3 over 2. 4 over 2 minus half is 3 over 2 plus 1 is 2 over 2. 1 is 2 over 2. Okay, so you got x raised to the power 2 over 2 minus 1/2, and that's going to be 1/2. Right? And this last one stays. And then we're going to take a derivative. And for each one, we're going to apply this formula. And that formula is, let me show you, derivative of x raised to the power of n with respect to x, right? That equals to n times x raised to the power of n minus 1. We're going to apply this formula to each one of them. So now we take a derivative. We write it this way, dy over dx. Dy over dx is d with respect to dx, the whole of it. The whole of it. And according to the sum and difference, and then we can take a derivative individually. Okay, we can take a derivative individually. So we're taking derivative individually. Okay, constant, they stay out and there, right? And next, what do? We apply this formula one by one. We have 3 terms, so we're going to apply it one by one. So 3/2, right? So in the first case, n is 3/2. N is 3/2. Okay, so we're going to follow this formula. Okay, so you have some piece of scratch paper, right? So this n, when this n is 3/2, and this n is 3/2. And this is 3/2 minus 1, right? You do this one by one. So the first term will end up to be 3/2. 3/2 minus 1. 3/2 minus 1. 1 is 2 over 2. Right? You're pretty familiar with that fraction. You should be. Okay. And then 3/2 minus 2/2 equals to 1/2. So now this exponent becomes 1/2. You just do it one by one. Okay. And you have a piece of scratch paper for you to play, to write it down in case you make any mistakes. And so here we look at this piece, right? And this time the n is 1/2. Here, you see that here n is 1/2. Okay, so this n is 1/2. So that n is 1/2. And this n is 1/2. Okay, and what does that equal to? Well, 1 is equal to 2 over 2, 2/2 minus, so this is a 2 over 2, 2 under 2, I'm going to throw. So this is going to be 4 times, 4 stays, okay, multiply 1/2, right, which is this piece, right, and x raised to the power of 1/2 minus 2 over 2, that's going to be negative 1/2. Ooh, okay. So this, if you work with purely with the exponents, 3 times. So now this time when we apply the formula, right, the derivative to the power of a negative 1/2. So this is a negative 1/2. N is negative 1/2. If n is negative 1/2, so this n is going to be replaced by negative 1/2, and this n will be replaced by negative 1/2. And what do we get? What do we get? Right, so this piece with that, right, so we have a negative 1/2 in the front, and x raised to the power of negative 1/2 minus 1. Minus 1 is minus 2 over 2. So this is going to be negative 3/2. negative 3/2. So this whole piece, which is this one, is going to be replacing this piece, okay? There. And we need to insert the parentheses because it's a multiplication. It's multiplication. And of course, you can put a negative sign in front of it or right here, right now, okay? But the way I write it, I try to make it easier to follow. So you should have paper, pencil with you and work with it, okay? So this piece is already simplified. And that piece you have 4 times half, and that's going to be 2, and x raised to the power negative half. Right? I probably should keep that, right? This is 4 times half. Okay. And the last piece, you're going to have a negative 3/2 and x raised to the power of negative 3/2. And the derivative is found. The derivative is found. Okay, so that's one way to do it. That's one way to do it. If you're being asked for derivative. All of these are really just your scratch paper. It's on the scratch paper. How many steps do you need to show? You can go from here directly here. So that this step can be skipped and get here. Okay. And then, well, this might look weird to you because I hear people say, "Oh, the algebra in calculus looks weird." That might be true somewhat. Okay, especially that we need some review on algebra, right? So practice with it so you get better at this. Okay, so now what if we apply quotient rule? What if we apply quotient rule? Okay, if we apply quotient rule, okay, if we apply quotient rule, you will get dy dx with respect to x. So we are differentiating with respect to x. Now we have a numerator on the top, and we have a denominator in the bottom. Right? So we can follow the quotient rule formula. So what do we get here? We will get, well, the denominator will be squared, right? The denominator g will be squared. There we go. And the numerator, we are going to differentiate the f, and the g is left alone. Okay, so g, which is the square root of x, we're going to leave it, and then we're going to differentiate the numerator. Okay, so let's first write this down. Subtracting, okay, f is left alone. Okay, what is f? F stays alone, no differentiation, derivative. So derivative of the denominator, which is the square root of x. So we have, if we apply the quotient rule here, that's what we got. Okay, and the next step, right? The square root of x squared is really x, right? And the numerator, you just differentiate this piece. There's 3 terms, you can do addition, right? So what are we getting? We're getting 2x plus 4 plus 0. and plus 0, we don't have to write it down. And the second part is the derivative of square root of x over the derivative of square root of x with respect to x. So what do we get here? You can use the formula that we did before, but since we know the derivative of square root of x is 1 over 2 times square root of x, we derive. You can work that out, okay, on scratch paper. So now we're having a slightly different form. And then what do we do? You can see we're getting something which looks different from what we did before, okay? But this latter one oftentimes is more useful, especially for our future contents, So we have a denominator here, 2 times square root of x. Then you would try to reduce it. Yes, we do. Okay, so how do we reduce that? Wait. Okay. We're going to try to reduce that. Common denominator, right? So we're going to multiply 2 times square root of x on the top. 2 times square root of x on the top. And 2 times square root of x in the bottom. And the bottom one will multiply with this piece. And the one, oops, that's not right. Okay, my bad. So 2 times square root of x to the bottom and to the top. Each one. There. Okay, you know what we did. Okay, so that you saw that. So we multiply the common denominator on top and bottom. The top has 2 terms, so we're going to distribute it. And now let's reduce it. You must do it along my side, otherwise it's very hard to follow. Now 2 times square root of x and 1 over 2 times square root of x, this piece is reduced. Right, over here you can write it as 2x. And now how about this piece? We have root x multiply 2 times root x. So that's really 2 times square root of x squared, right? Square root of x squared, that's x. Looks like we're getting somewhere, okay? Foil the top, and we always wish to have the answer in product form. Okay, so over here, you're going to distribute 2x. So you're going to get 4x squared plus 8x. Subtracting x squared, subtracting 4x. So we remove the parentheses. So this becomes subtraction. This becomes subtraction. And near the end, right? This is x minus x squared is subtracted from 4x squared. So we have 3x squared left. 8x minus 4x, that's going to be 4x minus 3. Well, this looks very different from what we got earlier. Well, which form will be preferred in the future? For now, either one as your answer is okay. Okay, but in the future, as we move towards chapter 4, we would prefer this form. We would prefer this letter form, okay? But for now, either one is okay. And of course, you need to make sure you get the right answer, okay? All right. So let's choose some other questions to work with. Like this one, example number 4. Okay. Find equation and of the tangent line to the given curve, right? So here, let's look at one of these. Find the equation of the tangent line to the curve at the given point. Okay. I didn't show the screen of the homework, and I figured you can find it. All right, so this question I have selected is this one. Okay, so y equals to 2 times e to the power x plus x. The given point is 0, 2. 0, 2. Well, the function obviously is differentiable everywhere in the domain of the function. The domain is all real numbers. So in order to find the tangent line to the curve at the given point, and we know that point is x equals 0, right? So let's take a derivative. So we take a derivative. dy dx. Okay, by this time, I think you'll be somewhat familiar with the notation. The more you use it, the better you're going to be. So this is the derivative. And we can use addition rule, right? And the first one, we get 2 to the power, 2 times e to the power x, the derivative of e to the power x, the same. And the derivative of x equals to 1. So we got the derivative function. This derivative function, okay, would be able to give us the slope of the tangent line at any point. So now we need the slope of tangent line at point 0. So when x equals to 0, that's the slope we want. You see the point given is 0, 2. The x coordinate is 0, so it's derivative is 0. So all we have to do is just replace x by 0 in this case. Okay, 2 times e to the power 0. E to the power 0 equals to 1. So that's going to be 2 times 1 plus 1. So that's going to be 3. So we found the slope and the line, the tangent line equation. Okay, a tangent line equation is y minus 2, right? There's a formula, we've seen that before. Right there. Well, we've seen that picture, we've seen that formula before, this formula, right, in the flashcard. Equals to the slope at 0 multiply x minus 0. And we just put numbers in place. The derivative of the function at 0 is 3. X minus 0 is x, right? So in the end, the slope of the tangent line equals to 3x plus 2. Finished. Okay, so that's one of the homework questions. There's another question we're going to answer, is that this is the example number 5. Okay. We have a question here. It's asked whether it's differentiable or not at a certain given point. Okay. So here's the question goes. So let the function be. Okay, let's clean it up. Okay, clean this. The function is piecewise function. 2 pieces. We have 2 pieces. Okay. So x squared plus 1 if x is less than 1. Excuse me. Just have a sip. X plus 1 if x is greater than or equals to 1. So apparently the function is defined at 1. The question is this: is f differentiable at 1? That is indeed, you can see that the question indeed is the case. I leave the sketch of the graph for you. Okay, you guys can select it. Okay, is it differentiable at 1? Okay, smaller than 1, we have a polynomial, it's differentiable. Larger than 1, function is differentiable, no problem. The only point that is questionable is when x equals to 1, because we have 2 pieces. In this case, what do we do? Well, we're going to have to examine the limit of the definition when h is approaching 0, f of 1 plus h minus f of 1 divided by h. So we need to assess, this we apply the definition. If we're going to assess if this limit exists. If this limit exists, right, then the function is differentiable at 1. If this limit does not exist, then this function is not differentiable at 1. So the definition is still very, very important to determine differentiability of a function at any specific given point, if that point is questionable. Okay. All right, so let's do it. Okay, so what is f of 1? Right, f of 1. Well, x is equal to 1. Well, x is greater than or equals to 1. So we're going to use the rule of x plus 1. So it's 1 plus 1 that equals to 2. But what is f of 1 plus h? And that would be interesting, isn't it? Because depends on if h approaching 0 from smaller than 0 or larger than 0. If h is positive, because h can approach 0 from smaller than 0. And that will lead to 1 plus h, that's going to be less than 1. Okay, so think out loud. So think out aloud. Right? If h is approaching 0 from smaller than 0, then 1 plus h is going to be less than 1. Right? If h is approaching 0 from larger than 1, then 1 plus h is going to be larger than 1. So now we have, not only we need to examine this limit, we also have to examine this limit by 2 sides. Look at the two-sided limit. Okay? So depending on 1 plus h sign, whether h is approaching 0 from smaller than or larger than, then we have to think of which piece of function we're going to use. Okay? To help us to see better, I'm going to actually draw a picture. Okay? Like, hopefully this will help you to see better. Okay, be patient with me. And I'm drawing this picture so that you can tell which piece of the function is going to be used. Okay. Don't worry about that. Y equals 0. I'm just going to draw these two functions, right? These two functions. When x is less than 1, we're going to use the color. We're going to use the color, say, we decide the color green. Oops, green. And this piece, we're going to use red. So that should be obvious enough, right? Very obvious. So what are we going to do is that we're going to help you to understand the situation we're in. So we have two pieces of functions. One is up to less than 1. Okay, so we're going to draw a piece of line to 1, and then 1, 0. Okay, don't worry about this because I'm just drawing these I'm using the software. You don't have to worry about how to use the software properly. Okay, I'm just trying to show you the picture. Oh, no. Wait. I made some mistake. Oh, we need a comma. -10, 0. There we go. Okay, what this says is that when x is less than 1, we're using this rule, x squared plus 1. Okay, so I'm going to apply the software. So this is, I don't need to be that long. Okay, so here we have x squared plus 1. And that piece, we're going to put it at -2, 0.1. It's green. Okay. There we go. So this piece we use x squared plus 1. Use this rule. And the other piece we use red, including 0.1. Okay. So this time I'm drawing this, right? So I'm going to draw a line. A red line. Okay. But also include the point 1, 0, which is that point. So on this red piece, we're going to use the other function. I hope through this process, of course, you're using your, if you have color pencil or whatever color tone you want to use, it would just be helpful for you to make it easy. So that way you don't even have to graph the function precisely. If you have any doubt, you just know there are two pieces, okay? If it's less than 1, you use the green. If it's greater than or equal to 1, you use the red. So the color is make it obvious as which to follow. And we were just discussing that f of 1, we know which piece to use. But for 1 plus h, we don't, because we could easily be less than 1 or larger than 1, right? So I would discuss that. So in order to assess this limit, right, we have to look at the limit. We have to look at the limit from smaller than 0. We also have to look at the limit when h is approaching 0 from larger than 0. I hope that's clear, right? So right now, I will show you in the end how do you organize your work. Okay. By this time, so now we're separated. Right? So to answer this question, this is questionable, right? We have to assess these limits. Okay, so think out aloud is also included. And we want to bring this little picture closer to us. Okay, we want to bring this picture closer to us so we can carry out, right? So when h is approaching 0 from smaller than 0, right? F of 1, we already know what it is. It's equals to 2, right? This is 2. The only thing is that if h is approaching 0 from smaller than 0, 1 plus h is less than 1. Less than 1, we're going to use the green. So this piece is going to be x squared plus 1. And what is x? X is 1 plus h squared plus 1. Right? F of 1 plus h. Right? So let me put it here. 1h, f of 1 plus h. Okay? Make sure you follow me. 1 plus h is less than 1. So we're applying that rule to x squared plus 1. So that piece, right, is going to be squared plus 1. Okay. Now we have, that's how we get this piece. 1 plus h squared plus 1. And wait, plus 1. How did I get it? Oh, sorry. Plus 1. So that's how we get this piece. Okay. And simplify, right? 1 plus h squared is 1 plus 2h plus h squared. Not 3, 2. And we simplify further. Right? So 1 plus 1, that's 2, 2 minus 2, that's 0. So these make 0. So now it's just 2h plus h squared. And we got a common factor h, right? So we factor this out. And h is factored out, right? And h and h are reduced. So by this time, we will have 2 plus h left. And then we can do direct substitution. That's going to be 2 plus 0 equals to 2. That's the limit from left. Okay. And how about the limit from right? The limit from right, we'll take this piece, right? F of 1 plus h, 1 plus h is greater than 1, that f of 1 plus h, we will be applying the other rule on the red, right? So f of x equals to x plus 1. So f of 1 plus h is going to be 1 plus h plus 1. And that, of course, gives us h plus 2. So now, so this piece is going to be h plus 2. Okay. 2 minus 2 is 0. So h and h will reduce. Right? These two makes 0. H and h reduce. So what do we get in the end? We get h divided by h. That's 1. H is approaching 0 from larger than 0, but h is not 0. So we can use property principle number 1. So the limit, final limit is 1. So what we get here is the limit from left and the limit from the right are not the same. And what do we say? That limit does not exist. Okay, so this limit does not exist. Does not exist. D and E. And then limit does not exist, therefore, the function is not differentiable at 1. Ooh, so now how do we organize our work? How do we organize our work? Okay, we have all thinking out loud, we have all these, and also we have applied that property, right? Limit from right and limit from left, right? We have applied this property, didn't we? Wait, where is it? I know we have it there. There, this one, right? We applied that limit, that property as well. So we did quite a lot of work. So now how do we show work? Show work, we have to put them in a logical order. Put them in a logical order for reader to follow. Okay. For this piece, right, we're going to put that in consideration because we're not going to put these question marks without answers, right? So what do we do here? What you really can show is you show this piece and that piece. Then do you have to show the reader that for this piece, you don't need to really. You really don't need to, this piece. Okay, you just leave it on the scratch paper. So you would say limit from left, plug in here, and put it there, right? And then you can say because or since, right? Then thus, well, then does not exist. If that does not exist, then you say f is not differentiable at 1. F is not differentiable at 1. Right? Do you need to draw this picture? No. Usually your teacher doesn't need to see that. Okay, you just have to show this piece will be sufficient. That will be sufficient. But you need to make sure your notation is right. Your notation, your operation, your notation is right. Right? That's how you organize your work. That's how you organize your work. Okay, of course you can put this one over here, f of 1, right? If you like. You can say f of 1 equals to that, right? And then you look at left limit, right limit. And that's it. That's all you need to show your work. There are other questions on product rule, quotient rule, which we already did some examples, and I will leave that for you to practice. So let's work on some derivative finding with trig functions. Okay, so this will make example number 4. Is it 4? Let's see. Let me check. 5. Oh, 6. This one is a 6. Okay. This time is differentiate. E-R-E-N-C-I-A-T-E. Differentiate. And one of the examples I can use is f of x equals to e to the power x Actually pick a somewhat easy, pretty easy one. Okay. Then you apply product rule. Product rule. Okay. So fast forward, product rule. There, product rule. You know the derivative of cosine, we know the derivative of e to the power x. So when we differentiate, that would be differentiating f of multiplied g, right? And then, of course, these they're all called f and g. So you have to make a difference which one is f, which one is g. So the derivative of e to the power x, right? You can write it that way. And g stay the same, plus e to the power x, and you differentiate cosine x. You can write it that way, right? And the derivative of e to the power x is the same as e to the power x, multiply cosine x, plus e to the power x. The derivative of cosine x is negative sine x. Now you're almost done. And as we prefer factor form. So now here we get a cosine x minus sine x. You're done. You're finished. Right? There are examples of that sort, and some of those does require some simplifying. Okay, so let's look at another one. So we can use quotient rule. And of course, this one is differentiating once again. And the function in consideration is like this. Okay, so y is equals to cosine x divided by 1 minus sine x, right? And we take a derivative of y. And that is to differentiate this piece. Oops. What am I doing? Come back. Okay. Differentiating there. Prop. Okay. Make sure you use the notation properly. Okay. Quotient rule. Quotient rule right here. Right. So that equals to square the denominator. So 1 minus x, 1 minus sine x is squared. And we differentiate cosine, that's going to give us negative sine, multiply, right? 1 minus sine x, right? We're following the formula. It doesn't change. Subtracting, and this time we're going to keep the f unchanged, right? Cosine x, and then we differentiate g, right? So we're differentiating g. G is 1 minus sine x, so we put a prime sign there, right? There are a variety of ways to express yourself. Some of you may do faster, and this derivative of 1 is 0. The derivative of negative sine x is negative cosine x. Oops, wait. That's it. But we're not done yet. We would like to reduce it, so the final answer is in factor form. So minus sine x times 1 and minus sine x times negative sine x. So this is going to end up to be plus sine square x. Okay. Negative sine x times 1, that's negative sine x. Negative sine x times negative sine x, that's going to be plus sine squared x. Negative cosine x times negative cosine x, that's going to be a plus cosine square x. There. Oh, okay. And then what? Then sine square x plus cosine x, that's gonna be 1. And we get a 1 minus sine x on the top. We got a 1 minus sine x on the top, right? We can put a 1 minus, so we can reduce it. So in the end, 1 minus sine x take away, 1 minus sine x, one of it in the bottom. And that's the answer. We can remove the parentheses. Okay, you can see differentiation does involve reducing, right? And this question, we're done. So that's some selected questions from derivative finding. And yeah, I think we can take a break now, okay? I will make another one to work on the limits, which is the last set of homework from last week. Okay, how do we work with those limits? Okay, all right, thank you for watching. And I'm gonna make another piece. Thank you.